Hello friends. In last lecture we learned what is amplitude modulation, its type and its parameter. In this lecture we are going to learn how to generate amplitude modulation based on power level. The amplitude modulation is divided into two types. First one is low level amplitude modulation and second one is high level amplitude modulation. Here power level is what is the power of carrier signal and modulating signal. Low level amplitude modulation. Modulation is performed on low power modulating signal and low power carrier signal, and to improve the signal to noise ratio of the transmission medium, amplification is done next to it. The examples of this low level amplitude modulation are square law diode and switch modulator. The block diagram of low level amplitude modulation is shown in the figure. Here we here we do modulation of baseband signal and carrier signal which are at low power, and then we perform power amplification. After that we transmit it through antenna. Next is high level amplitude modulation. Unlike low level amplitude modulation, here the first stage is of amplification of the signal, and the second stage is modulation. Its example is collector modulation method. In the block diagram you can see the modulating or baseband signal is getting amplified by wideband power amplifier, and the carrier signal is getting amplified by narrowband power amplifier. After that we perform modulation and then we transmit it through antenna. Generation of AM wave. To understand how to generate amplitude modulation wave, we need to understand mathematical equation of modulated signal. St is equal to A plus xt multiplied by cos omega t. In another term, St is equal to A cos omega t plus xt cos omega t. As shown in the above equation, we want multiplication of modulating signal with the carrier signal, and the mathematical equation looks easy, but to generate AM wave, amplitude modulation wave, it it is little bit tricky. A lot of circuit are there to produce amplitude modulation wave, and every year lot of persons uh, present their idea to generate AM modulation with different circuits. That is the part of research. We are not going to study all those circuits. In this lecture, we will study only those circuits uh, which are standard and well stabilized. So, so before going further, I will ask what will happen if we will apply carrier voltage and base voltage across a resistor. If we apply across the resistor, we will get uh, either sum or subtraction of carrier voltage and modulating signal voltage divided by resistance in the output current. So a linear system like resistor will only give addition or subtraction of two signal. It will not give multiplication. To get multiplication, we need some nonlinear system. The nonlinear system provide multiplication of two signals. How they provide, we will look in this equation. The generalized mathematical equation for nonlinear system in terms of voltage and current is I is equal to A plus BV plus CV k square plus D B ka cube plus so on, where A, B, C, D are constant, I is current, V is voltage. In above equation, if we put voltage V is equal to carrier voltage plus modulating voltage, then on performing the square of V in CV square term, we will get multiplication of VC and Vx. Square law diode modulation. So in last slide, I told why we need non-linear system, because it gives square of its output is in terms of square of input, and by squaring the input we get multiplication of two different input. So square law diode do the same thing. This is low level modulation, as diode shows non-linear characteristic at low voltage. In the left hand side, the block diagram of square law diode modulation is shown. Here, um, here we give input to square law device, and the input to square law device is modulating signal and carrier signal, and in output we get we get a bulky mathematical term, and we pass this output from to band pass filter to get modulated signal, desired modulated signal. In the right hand side, you will find circuit diagram of square law diode modulation. Here, a VCC voltage in addition to carrier voltage and modulating signal voltage is applied on diode, which perform which perform squaring of input, uh, and we pass the output of diode to band pass filter to get desired modulated signal. Let's understand the working of square law diode modulation through mathematical equation. In block diagram, V1 V1 is equal to MT plus AC cos 2 pi FCT, and V2 is equal to K1 V1T plus K2 V1 square T. When we expand this equation, we will get V2 is equal to K1 MT plus AC cos 2 pi FCT plus K2 multiplied by MT plus AC cos 2 pi FCT का whole square. When we expand this term, when we simplify this, we will get V2 is equal to K1 MT plus K2 M square T plus K2 AC square cos square 2 pi FCT plus K1 AC multiplied by 1 plus 2K2 divided by K1 multiplied by MT plus multiplied by cos 2 pi FCT. In this equation, you will see the last term is the amplitude modulation. That is, we want in the output of amplitude modulation. Uh, and and rest of terms we want to eliminate. This we do the elimination with the help of band pass filter. Through band pass filter, we will get only the last term and the other terms will get eliminated. This is the working of square law diode modulation. Now, switching modulation. Unlike square law modulator, where diode work in on mode only in non-linear region, in switching modulator, diode work as a switch on-off mode, and the switching of diode is controlled by carrier signal frequency. So in the output we get multiplication of MT and CT, and we pass with this band pass filter to get desired modulated signal. Now collector modulation method. Here it is a high level modulator where signal first get amplified and then get modulated. We amplify the carrier signal with class C power amplifier, and we amplify the modulating signal with class B power amplifier. In the circuit diagram, you will find that carrier is applied to base of transistor, and the modulating signal is trying to alter the trying to alter the collector voltage indirectly. Its name is collector modulation because the modulating signal is indirectly applied to collector terminal of transistor. The modulating signal is trying to vary voltage of collector terminal in accordance to it. So in output we get the multiplication of carrier and modulating signal. We will end this lecture here. Thank you.